Take a moment. Look around you. Really look. What do you see? What do you perceive? Maybe it's the comforting sight of a coffee cup, its steam swirling invitingly, or the warm embrace of sunlight filtering through a window, perhaps the quiet hum of a computer, a constant companion in our modern lives. We exist within a complex tapestry of ordinary moments, seemingly simple interactions, yet each one is governed by profound, underlying rules, the elegant and immutable rules of physics. Physics isn't confined to sterile labs and complex experiments, it's the fundamental script that reality itself follows, the code that dictates how everything behaves, the unseen architecture, the hidden framework, of absolutely everything we experience from the smallest atom to the largest galaxy. Understanding it, even just a little, is like learning the secret language of existence, unlocking the universe's hidden secrets. Physics elegantly explains why a ball arcs gracefully through the air, following a predictable path, why the sun, millions of miles away, warms us with its radiant energy, and why distant stars twinkle in the night sky, their light bending through the atmosphere. Every single action, from the simple act of walking to the complex coordination of texting on a phone, is physics in constant, beautiful motion. To truly study physics is to pull back the curtain, to reveal the intricate mechanisms and hidden processes that make the world work. Ancient civilizations, long before modern science, meticulously charted the skies and passionately debated the nature of matter and motion. In their own way, they were already doing physics. This inherent human curiosity, this drive to understand, is what fuels the physicist's endless journey, ultimately leading to groundbreaking discoveries that reshape our understanding of the universe and transform our world. As we embark on this exploration, I encourage you to set aside any initial fear of complexity or daunting equations. Instead, think of this journey as a fascinating tour of the fundamental pillars that are silently upholding your entire world. We'll gently touch on the concepts of motion, how things move and interact, the invisible forces that shape our reality, and the ubiquitous presence of energy, not as abstract formulas confined to textbooks but as tangible realities that you actively interact with every single day of your life. Ultimately, this is the grand story of everything, the universe in its entirety, and you, yes you, are an absolutely central and indispensable character within this incredible cosmic narrative. Everything in the universe is in motion, a constant dance of cosmic entities. From the smallest particles to the largest galaxies, nothing is ever truly still. It's a dynamic, ever-changing spectacle. Even a book sitting on a table, seemingly at rest, is hurtling through space along with the Earth. We often perceive things as stationary, but that's just relative to our own moving frame of reference. Motion, at its core, is simply a change in position over time. It's the fundamental concept that governs how objects move from one point to another, and physics provides us with the precise language and mathematical tools to describe it, analyze it, and even predict it. It allows us to understand the how and why behind movement. Velocity isn't just speed, a simple measure of how fast something is moving. It's speed combined with a specific direction, a crucial detail for accurately mapping any object's path through space. Knowing the direction is just as important as knowing the speed. Inertia is an object's inherent resistance to changes in its state of motion. It's the tendency of things to keep doing what they're already doing. An object at rest tends to stay at rest, and an object in motion tends to keep moving at a constant velocity. This is the essence of inertia. You can directly feel the effects of inertia when a car accelerates rapidly, pushing you back in your seat, or when it brakes suddenly, causing you to lurch forward. Acceleration, then, is a measure of how quickly an object's velocity changes over time. This could mean speeding up, slowing down, or even simply changing direction. Even a car maintaining a constant speed while driving around a curve is in fact accelerating, because its direction is constantly changing as it navigates the curved path. These fundamental concepts, velocity, the rate of change of position with direction, inertia, the resistance to changes in motion, and acceleration, the rate of change of velocity, are the essential building blocks for describing and understanding everything from the arc of a baseball's flight all the way to the complex trajectory of a satellite orbiting the Earth. They provide us with the tools to predict where things will be in the future, and crucially how long it will take them to get there. By quantifying motion through precise measurements and mathematical relationships, physics transformed from a descriptive discipline into a powerful predictive science, moving beyond simply a philosophical exploration of the natural world. The insights of early physicists provided us with the fundamental tools to observe, meticulously measure, understand, and ultimately anticipate the mechanics of the world around us. Motion isn't just an abstract concept confined to textbooks and equations, it's the very foundation upon which everything moves, interacts, and changes in the universe. And it all begins with a deceptively simple question, a seed of curiosity that sparks a journey of discovery. What fundamentally happens when things change their position in space and time? If motion is the story, forces are the authors. A force is a push or pull that causes objects to accelerate. Without forces, nothing would ever change. Objects would stay at rest or move forever in a straight line. Gravity pulls us to Earth. The normal force keeps us from falling through the floor, and friction lets us walk and stop cars. Beyond these, four fundamental forces govern all interactions: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Every push, pull, and interaction is a manifestation of these forces. Understanding forces lets us build bridges, launch rockets, and open doors. By quantifying these invisible pushes and pulls, physics empowers us to shape our world. Forces aren't just abstract, they're the reason anything happens at all. They transform us from passive observers into active participants in the universe's grand design. In the 17th century, Isaac Newton distilled centuries of observation into 3 laws of motion. The first law of inertia, says objects stay at rest or in uniform motion unless acted on by a force. The second law links force, mass, and acceleration F equals sign mxa. More mass means more force needed to accelerate. The third law, for every action there's an equal and opposite reaction. Forces always come in pairs. These laws explain everything from pushing a car to launching a rocket. They govern the flight of cannonballs, the orbit of planets, and the collision of billiard balls. For centuries, Newton's laws were the final word on motion. While quantum mechanics and relativity have expanded our understanding, Newton's laws still describe our everyday world. Simple, elegant, and powerful, these laws are the foundation of classical physics. Newton's legacy, a universe that can be understood through clear, universal rules. If forces drive change, energy is the currency that pays for it. Energy is the capacity to do work, applying force to cause movement. It can't be created or destroyed, only transformed. This is the law of conservation of energy. Kinetic energy is the energy of motion. Potential energy is stored by position or state. A book held high has gravitational potential energy. When dropped, it becomes kinetic. Energy transformations power everything. Water behind a dam turns turbines, generating electricity that lights your home. The chemical energy in food fuels your muscles. Gasoline powers your car. Even sunlight is nuclear energy from the sun's core, sustaining life on Earth. Energy is never lost, just changed from one form to another. Understanding energy lets us harness power and build technology. It's the thread connecting all physical processes. Energy is the ultimate fuel of reality. Every action, every change, is paid for with energy. The universe, in its vastness, is a symphony of energy and information. It's a dynamic, ever-changing landscape where everything is interconnected through invisible forces. And much of this energy and information travels in the form of waves, rippling through space and time. At its core, a wave is a disturbance, a fluctuation that moves through a medium, be it air, water, or even the vacuum of space. This disturbance propagates, transferring energy from one point to another, without actually moving the matter itself. It's like a crowd doing the wave. The energy moves, but the people stay in place. Sound, for instance, is a pressure wave that travels through the air, vibrating our eardrums and allowing us to perceive the world around us. Light, on the other hand, is an electromagnetic wave, a different kind of wave altogether. What's fascinating about light is that it can travel even through the emptiness of a vacuum, unlike sound, which needs a medium to propagate. It was James Clerk Maxwell who brilliantly showed that light is actually a self-propagating wave, composed of oscillating electric and magnetic fields intertwined together. And light's speed, an astonishing 300,000 kilometers per second, is not just fast, it's the universe's ultimate speed limit, a fundamental constant that governs the cosmos. The color of light, the vibrant hues we perceive, depends directly on its wavelength. And the full range of these wavelengths is what we call the electromagnetic spectrum, stretching from the longest radio waves to the shortest, most energetic gamma rays. Interestingly, most of this vast spectrum is invisible to our human eyes, yet it's the very foundation upon which many of our modern technologies are built. From the microwaves that heat our food, to the X-rays that allow us to see inside our bodies. These waves are not just carriers of energy, they also carry information, enabling us to communicate across vast distances, connecting people and cultures across the globe. By detecting and interpreting these waves, we are able to reveal a world that exists beyond the limitations of our natural senses. Understanding the principles of waves allows us to broadcast signals through the air, to see inside the human body with incredible precision and to explore the furthest reaches of the cosmos. Indeed, the universe is constantly humming with invisible vibrations, a symphony of electromagnetic radiation, profoundly shaping our perception of reality, influencing what we hear, what we see, and ultimately, what we know about the world around us. And by diligently studying these waves, by developing sophisticated instruments to detect and measure them, we are constantly expanding the reach of our senses, pushing the boundaries of human knowledge and deepening our understanding of the very fabric of reality. By the 20th century, Newton's physics seemed complete, until two revolutions changed everything: relativity and quantum mechanics. Einstein's relativity showed that space and time are woven into space-time, warped by mass and energy. This is gravity. Special relativity revealed time dilation and length contraction. General relativity predicted black holes and the bending of starlight. Quantum mechanics describes the bizarre world of atoms. Particles can be in multiple places at once and their properties are uncertain until measured. Energy comes in discrete packets, quanta, not continuous flows. Relativity explains the cosmos. Quantum mechanics explains the atom and underpins modern technology. Yet these two theories are fundamentally incompatible. We still seek a unified theory for the extremes of the universe. The quest for a theory of everything continues. Physics isn't just theory, it's the backbone of modern technology. Your smartphone's touchscreen uses electromagnetism. GPS relies on relativity to stay accurate. Cars run on thermodynamics and friction. Their electronics follow the laws of circuits. Medical imaging, MRI, X-rays, PET scans, uses quantum mechanics and electromagnetic waves to save lives. Fiber optics, heating systems, and even the grip of your tires are all products of physics. Physics is the foundation of engineering and the conveniences we rely on daily. Centuries of inquiry into nature's laws have built our modern world. The pursuit of physics empowers humanity in ways we often overlook. We've journeyed from motion's elegance to the mysteries of space-time and the quantum world. Physics is the operating system of reality, explaining everything from falling apples to shining stars. Its principles, force, energy, motion, waves, are the universe's vocabulary. This knowledge has let us shape our destiny, from splitting atoms to exploring space. Yet the greatest mysteries remain: dark matter, dark energy, and the unification of physics' two pillars. The quest for understanding is ongoing, connecting us to the cosmos and revealing our place within it. Physics fosters wonder and humility, empowering us to comprehend the universe's staggering complexity. To study physics is to join humanity's greatest adventure, understanding the fundamental nature of reality.